a difference of squares. So it's a difference of squares. Okay. Sometimes people call this a difference of two squares. It depends on what resource you're looking at. Okay. We have also done these problems because really essentially all these problems are just multiplying two binomials together. And we've done that. These I'm just introducing to you as special types of products that you would get. Just like you knew multiplication before you knew that 2 times 2 gave you 4, which was a perfect square. These are things that, they're just special products, right? 2 times 2 is a special product. 3 times 3 times 3 is a special product because it gives you a perfect cube, right? So that's sort of the idea here. So let's talk about difference of two squares. So a difference of two squares generally looks like this. So in its factored form, it's going to look like this. Okay, so the way you can identify a difference of two squares in the factored form, which is what we have right here, is that the binomials look the same, right? The only thing that's different is the sign in the middle. Okay, I like to say, and I don't know if this is sort of like a technical term, but I like to say that it is the same terms with opposite signs, sort of opposite or different signs, meaning that I have in my binomials, I have an A here, an A here, a B here, whoops, and a B here with different signs in the binomials. So opposite signs in the middle, right? I sort of shorthanded that there. So let's go ahead and multiply this using FOIL method, okay? This is good practice with FOIL. So we are multiple distribution, A times A. Recognize that it is as A squared. Going to the outside by multiplying A to the second term of that binomial, A times negative B is negative AB. Going to the next set of distribution, multiplying B to both terms in the second binomial, B times A is AB. And then B times negative B, watch for your signs here, is negative B squared, right? So let me fix that. So this is what you get. Again, you want to make sure that you combine like terms. What's really unique in multiplying difference of two squares is what happens when you do combine your like terms. What happens to those like terms? Well, the like terms, they cancel. They cancel out, they cancel to a 0. And we're not going to write 0AB. That's just not the way we write it, because that's not simplified. So then we get A squared. These are 0. Some people, when they cancel out to 0, like to cross them out. That's completely up to you, how you want to handle that. I'm going to erase that, though. And then there's not those combined to 0, so I'm not going to write 0AB. And then I'm left with a minus B squared. And then here is your answer. Now, what's unique about the product of a difference of two squares are a couple things. First of all, the simplified product, it will always simplify to two terms. Okay. The next thing is that both terms are perfect squares. Okay, and there will be a minus between the two terms of the product, right? So that's how you can recognize that you had a difference of two squares factored form, is the way that the product looks at the end. Okay, so let's try an example of this. Okay. So here's our example. So our example here, we will try, let's make it really similar to the last one that we just did. I guess we can do 2x plus 1 times 2x minus 1. Really similar, Same sort of terms. So this is, I'm already recognizing this product as a difference of two squares. Both the binomials look almost the same. The only thing that's different in them is the sign in between the two terms, a plus here and a minus here. So let's go ahead and I'm going to give you guys a second to pause your computer so that you can try this one on your own before we move on. Okay. All right, so you should have tried this, and in doing so, this is what it would look like. Going with the first term by distributing this first term to everything in the second binomial. Here's your first, right? 2x times 2x is going to give you 4x squared. And then going to the outside terms, your second distribution there into the second binomial, we have 2x times -1, which is -2x. And now we're going to go ahead and distribute the 1 to every term in the second binomial. Remember, this is the inside terms of FOIL, if that's what you're thinking about. 1 times 2x is 2x. And then finally, the last terms, we have 1 times -1. Pay attention to your signs. You get -1. We can see here that our like terms, here and here, those are going to cancel out to be 0. You do not need to write 0x because it's just 0. So we're going to go ahead and combine those to give us 4x squared minus 1 because there's nothing to combine with the squared term, or there's nothing to combine with this constant. So this is what we end up with. Okay, so that's a really messy box, huh? So we can see here that our problem, still really messy. Our problem here, we have 2 terms left, right? 1 term, 2 terms, minus sign in between. Both of those terms are perfect squares. 1 is a perfect square because 1 times 1. 4 is a perfect square, 2 times 2. X squared is a perfect square, x times x. So if 4 is a perfect squared and x squared is a perfect squared, together they are also a perfect squared because it's 2x times 2x, right? So that is what we would call, if someone said, what does this product represent? You would say, well, that's a difference of squares. Right? So there you have it. The two special products, a difference of squares. And the first one we talked about is a perfect square trinomial. And you can see what they look like before you start the problem and the characteristics that you get at the end of the problem when you have your product. So I hope this helped. Please let me know if you have any questions, and good luck with your assignment on this.